some I'm not really good at all this YouTube stuff, so I'll just quickly do an introduction. So my name is Divine. I'm studying computer science in my university, and I'm here to teach you Marie, because when I was trying to study it, I was having hard time looking for sources on the internet. So I just decided to make you guys' life easier by showing you how to code Marie, basically everything you need to do know about Marie. So what is Marie? I have some quick notes on it. So Marie Sim is a computer architecture simulator based on Marie architecture and designed to teach beginners computer organization and architecture. That's it. So side note, I'm not a teacher or anything. I'm just a normal student that have problems understanding Marie because I couldn't get the right sources, and I just don't want anybody to go through it again. So yeah, that's it. So there are two ways you can write Marie programs. I'm guessing already that you guys already have your teacher has already given you like a source to download your Marie program from. If not, I you need to download Java JDK, right? So you have to come to this website to download the JDK, and I'll put the link of it in the description below. Then you come to Windows, and depending on whatever laptop you guys are using, technically that's what you're going to use, and you just download whatever that suits you. But I'm not going to do it because I already have JDK on my system. And if you don't already have Marie on your computer, or if you don't know how to operate it, there is an I'll say online coding editor for Marie, which is this. Don't worry about the code, we'll get into it. I'll just testing it out to see how it works exactly. I am going to be coding here, but for those of you that don't have, you can code on this website. The link is in my bio. I'm going to be showing you how to code everything in Marie. So for those of you who your lecturer already gave you like the materials for it, it's going to be looking something like this, all right? So you have to come here, you go to edit, you click file, then go to edit, and it will bring out your code editor. So this is where you write all your code, right? And in Marie, we have, just like any other code, we have syntaxes. Anytime you're coding, there is a syntax you have to use, which is org 100, right? Then the syntax is in Marie, syntax in Marie. Okay, so we have load. I usually write it in capital letter, I don't know why. I write the syntax in capital letter. We have load, we have add, we have substitute. I will expand this for you guys to see it well. Yeah. So there's outputs, there's jump, there is halt, there is keep cond 000, and I'm coming. As a programmer, you're lazy, and yeah, I'm a lazy person. So yeah, there's keep cond 800 and 400. What else is there? So there's load. Okay, there's store. There's store. That's everything you need actually to program. So we have load, add, substitute, output, jump, halt, skipcon 000. I never actually used skipcon 000 or 800. I only used 400, and 400 means skip the next instruction when your variable is at 0. I would explain it more. It's just right now, just understand that, okay, when we go into the course more, you would understand what I mean. All right. The first thing you want to do is org 100, right? Let's take it down here. So let's make it more professional. Org 100. We want to store 3 and 4 inside a variable. For those of you that don't know what a variable is technically like a safe where you keep information inside. So Marie doesn't know what is 3 and Marie doesn't know what is 4. We have to store 3 and 4 inside a variable. And how do we do that? Let's say 3 is x. We do x, comma, dec, space, 3. So now 3 is stored in the variable x. Now to store 4, you can do y dec 4, right? Now, first step, org 100, second step, your variables, right? Then what's next? We need to load x. What happens when we load x is the AC is 3. It's going to load what's inside x to the AC. And this is what, and so the AC is going to be 3, right? Okay. Now we need to add y. So now what's happening is it's going to add 3 plus 4 in the AC. So now the AC is equals to 7, right? And when we output the results, the output is technically print. It's going to output the results. And we end our program by writing halt. Now, in order for this to work, we need to save our project. So save as, and I would save it in my downloads, probably just save it as YouTube 1. And we're not going to save it as all files, we're going to save it as mass. And we save it, right? Then we assemble it. Assemble current file. So it says there's one error. It says CMV listing YouTube, blah blah blah, instruction not recognized, add. So probably this is wrong. That's not for commenting. Assemble is probably gonna work now. Look, if you look right down here, it says user assembly successful, right? So for those of you using this guy alpha here, all you have to do once you've written the code here, you just click this assemble. So it's assembled, right? And if you would want to output it, you also have to make sure this is on decimal, and you press run. So this is 11, right? Well, for you guys here, once you're done, you have to save the file and assemble it. Then you come to your Marie simulator and you have to load the file. So you go to your anywhere you start the file as is where you're going to load it from, and you're going to open it. And this is the file here. And when you press run, you have to make sure this is also decimal too. Alright, so this is decimal. Then you click run, and it prints out 7. So that's how to add in Marie. There's also something I want to tell you guys. When you load X into, so now notice that X didn't change, because if I output the result and I load X again, I load X and I output it, technically I print it out, that's what I would say. You would see that X is still going to be 3. X didn't change. File, you have to assemble. Then we have to come here and reload. Then we have to run it. Look, so we added y plus x in the AC 7. Then we loaded x. So when you load x, it just overrides what's in the AC. So there was 7 in the AC. and it puts x now 3. X didn't change. The value of x didn't change. Nothing happened to x because we didn't store anything, right? X was x. We didn't change x. Now, if for instance we said load x, add y, store x. Well, technically saying load x, so in the AC there's 3, add y, in the AC that's 4, so now 4 plus 3 is 7, so the AC is 7, store it in x, so now x is 7, output it. Let's see what's going to happen. For us to do that, we need to assemble current file, then we come here and we reload and we run. See, so load x 7, no 3, add y 4, that's to the AC, store it in x, x is now 7, output it. When you say output, it's outputting what's in the AC, right? Then we said load x, loaded x to the AC, and we output it. And now we halt. Halt means end of code. So that's it. So let's assign x to be 7, and let's assign y to be 2, right? It's technically the same thing. You have to start with org 100. We need to load x, right? Then we need to subt y. Subt y means substitute y. So it loads x to the AC, then it substitutes what's in the AC with y. So the AC is 7, then it substitutes 7 with 2. It doesn't affect x or y. X is still going to be 7 and y is still going to be 2, right? Because we didn't store it. And we output. And halt. We assemble it, and we go to Marie, file, reload, run. 5. If you guys are doing like a big step of code and you get confused at some point, there is this function called step. So what step does, it goes step by step. The AC is 0, right? Let's do step. Now the AC is 7. Substitute y. AC is 5. 7 minus 2, 5. Output 5. Halt. That's all. You know, as much as I'm doing this, if I feel like I'm not really getting engagements from you guys, or like you guys are not communicating with me, I don't know if I'm doing it good or bad. So you guys should let me know what you think, if the video helped you out, how you found the video, and yeah, like and follow and subscribe. Thank you. Okay, now we're going to do loops in Marie. What exactly I want to do with this is I want to interpret this Python code in Marie. Let's see what it does in Python, right? So I'm going to open PyCharm. It's just for coding Python codes. Yeah, range 1 to 100, so we have to flip it then. Yeah, so it prints from 1 to 99. That's what we want to translate in Marie, right? Also, for you guys that are using this website, all you just have to do is, once you're done writing the code, just assemble it and run it. Where's the run? Assemble and run. Technically, you start with that. So yeah, and you run. That's all. Print from 1 to 99. And from looking at the code, it goes from 1 to 99, so we know already that that's going to loop 99 times. We need 3 things. Well, let's start with org 100, give it a space, 2 space. Then we need x x is going to be 1, x is decimal and it's going to be 1, y it's going to be, we'll say 1 is 1, and the counter, we call it c. Actually, I don't want to be right. It's 99. Right, so this is the starting value. This is starting value. Load x. We want to load x. We want to output whatever x is, right? And we want to add 1 to x, because see, add 1 is going to add variable 1 to the AC, right? And what's in the AC? X. What's x? 1. But we need to store it, so we're going to store it in x, because why not? We're going to load c, add 1, store x, load c. So now we're loading c and we're going to substitute 1 from c. Do you know why I'm substituting 1 from c? So I'll explain in a second. Actually, so in order to start a loop, you need to call the loop something, right? So we said arg100, then we need to call the loop something like you could probably put like David, comma, and start from there. But I usually just like writing a loop because it just, I mean, it's a loop, so it just makes everything more better. Like your naming convention should actually be good. Okay. Right. Store. So we're going to store 98 in C. Then we're going to check if it's 0, and if it's not 0, we want to jump to loop, and if it is 0, we want to halt. All right, so let me tell you what the code does. So the code says load x, right? So when you load x, x is 1, right? Output it. So now this is we outputted 1. Then we're going to add 1. So the AC is going to be equals to 2, right? Then we're going to store x. So now x is going to be equals to 2, right? Then we're going to load c. Don't forget c is 99. So that c is equals to 99. And we're going to substitute 1 from c. So now, okay, c is equals to 99, and the AC, what's in the AC now is 99, not, it's normal 2. So we're going to substitute 1. So now AC is equals to 98, and we're going to store C. Now C is equals to 98. So we're, technically when we say store C, we're saying store whatever is in the AC into C. I think that's the best way to explain it. And we're going to check if C is equals to 0. If it's equals to 0, halt. That is end the code. Halt means end code. End program. I think that's the right word for it. And if it's not equals to 0, it should jump back to the loop. So it's saying go back to loop and do it again. So it will keep on doing it till C is equals to 0, and it will stop. So let's run the code. So I'm going to save as, I'm not going to save it here because, you know, I'm going to say loop 1, save, and we need to assemble it. Don't forget. Oh, I see the problem. I already know what the problem is. So if you this was capital letter C and now it's not, because I was wondering it's difficult to debug it. So now it runs perfectly, right? And just make sure you try and assemble it before. I mean, you can't technically load it if you don't assemble it. So you might as well just assemble it before trying to load it. And if it throws error, just try and solve it. And if you can't solve it, just copy your code, put it into ChatGPT, and ask ChatGPT what's the problem. It's to give you some insight into it. You guys should pay me actually, but don't worry. I'll get payments in a different way. Just um, comment if the video helped you, what you would like to learn next, and like and subscribe if you're new, because I'm going to be posting similar content like this, like K-map, Boolean logic, all those things. Just yeah. Oh yeah, so we're going to load, and we're looking for loop. This one. This is right here. So if we run the code, let's see. So it keeps on printing. It's probably meant to stop at 99, but it might stop at 98 or 100. I didn't really calculate it, but I think it's 99 it's going to stop at. Boom! So that's it. There's so much to give me congratulations. So yeah. So I'm sure you guys are pretty excited because it's technically the same thing as what's in your Python code right now, if you hear me. So yeah, that's crazy. All right, let's go to question 2. Yeah. So yeah, already I kind of understand what this code is saying, but let's just run it. Okay. No, that was fast actually. All right. So the code is saying for x in range 33 5 minus 3. So you're starting from 33. X is equals to 33, right? I'm going to put a hashtag there so it doesn't really cause any trouble, right? And here it says y is equals to 2. Okay, x is equals to 33, y equals to 2. Then it says sum plus equals to x plus y, right? So that is saying sum is equals to the addition of 33 plus 2, which is 35, which is what you have right here if you look at it, 35, right? And it prints out x plus y. That's when it prints it out. So for every time x plus y are combined, it adds it to sum and it prints out x plus y. Then at the ending of your loop, it prints out the combination of everything here. That's 1440. On a normal day, like, you're not meant to be talking while teaching, you feel me? But I feel like it's more engaging if I'm talking with you guys. I mean, it depends on you guys. If you guys say I should shut the fuck up, I will shut the fuck up. But you tell me in the comment section. That's it. But if you guys like the way I'm talking and teaching you guys at the same time, then I'll probably just continue doing it. Break the question down as it's being solved. If you know what's happening, because this is technically what's happening, he gets x, he gets y, he adds them together, he outputs them, he stores them inside sum, and he keeps on doing it, right? So we know the first step is load x, add y, output, store sum, then load counter. Let's work on the inner loop first. Let's call it inner. Right, inner says inner comma load x. Let's define it here as we're coding. So x equals to 33, right? Load x, add y, and we know y is equals to 2, right? And we're going to cosmic, oh no, output, add sum to it. So whatever is in sum is going to be added to what is in x plus y, and we're going to store sum, right? And we have to define sum, so we know sum is initially 0, right? And for every time we do it, we want to load inner C, or let's say IC, just makes it better. So IC is going to be the counter for range for the inner loop, right? That's 2 and 8. So how many times is it going to loop through it? So it's going to loop through it 3, 4, 5, 6, 7, 8, 6 times, right? 6 times. So we'll probably have to define IC as 6, right? Load IC, and we have to define, because we're going to be substituting 1 deck 1. So load IC, substitute 1, store IC, then we're going to check if it's 400, right? If it's 0, if it's not 0, we are going to jump back into the loop, and if it's 0, we're going to load x, add y, output it, add sum, store sum, load IC, substitute 1, store IC. Right here we should probably, after we've stored sum, we should probably load y and add 1 to it, and store y, then load IC, substitute 1, store IC, skip 1. So what I'm saying is, like, load x is 33, add y, that is 35, output it, so we have 35, add sum is 0, so the AC is still 35, store sum, now sum is 35, load y, that's 2, add 1, that's going to be 3, store y, so y is now 3, load IC, substitute 1, store IC is now 5, skip count 400, no, it's not 0, jumped into the inner loop. It's going to keep on doing that again and incrementing y and decrementing IC until IC is 0, and when IC is 0, y is going to be 8. Then it's going to let's halt it. Let's see what it's going to give us. Let's test it out first, right? Yeah, so assembly current file. So it's throwing an error now. Okay. Alright, so I found the error. If you look right here, it's DCC not deck. So yeah, so in Mari language you have to be really careful, because like if you're not careful, any small mistake is going to throw an error to you. So it's very like strict in terms of syntax and everything actually. So now I've successfully assembled the program. Then we can go to Mari and we can reload. I think everything's going to change and we can run the program. Let's see what it gives us. Let's see this. So this is what we want. This is what we want right here, right? This is what we want. So that's 40, stops at 40. So that's good. That's pretty good actually. So now let's work on the outer loop. Now, what we want to do is, so we know at the end of the loop, IC is going to be 0 and Y is going to be 8. We want to load IC and add, boom, add 6 to it. So I'm just going to create a variable called 6. That's decimal and 6. And we're going to store it in IC. Then we want to load Y and substitute. So 8 minus 2 is 6, so substitute 6, so it plays out well. And store 6, store Y. Y is going to be 8, because right here, because in Python, if you look at, it says for Y in range 2 to 8, so keep on adding to 1 to Y till it reaches 8, then stop. So at the end of the loop, we know Y is going to be 8. So if Y is 8 and it goes up here and it minus 3 from 33, so that is 30, right? We don't want to do 30 plus 8, we want it to be 30 plus 2, then 30 plus 3, then 30 plus 4, because that's what's implemented here, 32, 33, 34, 35. That's what we want to do. So to avoid it, we have to reset Y back to 2. And how do we do that? We minus Y, which will give us 2. That is what we did in this code right here. That's what we did right here. So we said load Y, substitute 6, and store Y. And the same thing for IC, because IC is 6. And at the end of the loop, IC is going to be 0. So we have to add 6 to it, so that this guy's right here, so it will be, they'll be back to their original self. That's the best way I can explain it for you. If you guys don't still understand, then just leave in the comment section what you don't understand, and I'll try and make a video explaining it more, where I'll probably just use a whiteboard marker and just write it down for you guys. But yeah, so that's load Y, substitute 6, and store Y. So now we have reset all the values. So now we want to load X. So if you notice, X decrease by 3 every time. So X decrease by 3 every time the while loop runs and goes. Look at this. While loop, so it's 33, it comes here, is 33 plus 1, 33 plus 2, 33 plus 3, 33 plus 4, 33 plus 5 to 8. It comes back here, minus is 3 from 33, it's 30, 30 plus 2, 30 plus 3. Do you understand what I'm saying? So I feel like that's enough explanation. So you come here, load X. So we're going to substitute 3 from X, but there's no 3 here, so we have to define it. So yeah, like as you're doing it, just define it. So yeah, substitute 3 from X, 3, and store 3. And then we're going to load. We also need a counter, if you guys remember. So we need to load OC. Yeah, so OC is like outer counter. How many times is the loop for the first loop going to run? It's going to run 11 times. How do I know? I already know, but I'll just tell you how I know. Because it's just like 33 divided by 3 is going to be 11 technically. So it's going to run 11 times. Yeah. If you don't still understand, then just comment, all right? And you guys don't understand, try replying to the people that don't understand the comments. So if you watched the video and you understood, try commenting and try looking at least 1 or 2 people that did you understand some parts and explaining to them. I'll still personally do a video, but enough talking, let me get to it. So load X substitute 3, store 3, load OC. OC is going to be 11. And I'm going to be substitute 1. No, substitute 3 because that's what. Actually, substitute 1. Yeah, and store OC. Yeah, and then I'm gonna check if skip count 400 are you 0. No, if you're not 0, I would like you to jump to inner, and if you're 0, I would like you to load sum, and oh yeah, see, that would have been an error, and output it, and I would like you to halt. So let's quickly go through the code. Let me assemble it first to make sure it's correct. So good. From jump inner from here. So load IC 6, store IC is back to 6. Load Y, substitute 6, store Y is back to 2. Load X, this is the inner loop right here. So starting of inner loop. Or outer loop. This is starting of outer loop. So load X, substitute 3. So now it's 30. Store it. Oh, store X. By the way, it's like 9 p.m. over here, so my brain is kind of tired. Load OC, substitute 1, store OC, skip count 400 is OC equals to 0, no, jump back into the inner loop. So it jumps back to the inner loop and it says load X 30, add Y 2, that's 32, output it 32, add sum 32 plus 35, which will be 67, I think. Load Y, add 1, store Y, so now Y is 3. Load IC, substitute 1, store IC is 5. Skip count 400, no, jump inner loop. So it's going to run the inner loop 6 times before going to the outer loop and coming back again. And let's check out the code. File, you reload, and so let's run it again and hope it doesn't mess with us. So now it's working. Okay, and then we're just gonna chill. And hey guys, if you stayed this far, like I said again, like the video, comment, and subscribe, and share with a friend. So it's giving 1485. So what happened was it ran one more step, which is not meant to. So to solve that, we just have to change this to 10, actually down the number of iterations to 10, not 11, and just run it again. Yeah. Yep. I'm actually tired, I'm not going to lie. It's 10 p.m. right now. I'm actually tired. So look, the answer is 1440, and if you go to your Python, your answer is 1440. It's the same step, like the same exact step. 32, 33, 34, 35, 36. If you go to your Mari, you get the same thing. 32, 33, 34, 35, 36. 30, where is it, sorry, 40, 32, 33, 35, 36, 37, see, that's it. And yeah, that's your code for Mari. Yeah, you guys would probably want to get the code. I just thought about it right now. So, um, a part of me is actually saying I should not give you guys the code. That you guys should type the code by yourself because of muscle memory. Actually, yeah, because of muscle memory, you guys should type the code by yourself. So, like, comment as usual, subscribe, and share with a friend. If you guys just really learn to marry from me, then just share with a friend. If you help me, help you, help them. Question 3 is actually stressful. I really don't want to do it. But I'll do it, and yeah, just for you guys, you feel me? And paste it right here. And if we run this code, we're going to see that it gives us a series of minus and plus. Now let's analyze the code. The code starts from y. So it says for x in range 9 to 18. So that says x is equals to 9. And it says for y in range 0 to 4. So y is equals to 0. Print mod x, y. So this is a function. And this what the function says is first val is going to be equals to x, and second val is going to be equals to y. First val minus 8 x, which is 9, minus 8, which is going to be equals to 1. Second val is going to be y, which is 0. All this is equals to 0. Your answer, which is your answer, minus 4 will be equals to minus 4. So your answer is going to be minus 4 in the first equation, and that is how they got minus 4 here. And it's going to run again. X is going to be 9 and y is going to be 1. First y is going to be 9 minus 8, which is 1, times 1, and this is going to be 1. And 1 minus 4 is going to be minus 3, and that's how they got their minus 3 right here. So this is going to run 4 times before this loop is satisfied, and once the loop is satisfied, it's going to go right to x, and x is going to be 10. So now if x is 10, y is going to be 0 once again, and it's going to be 10 minus 8, and this is going to be 2 times 0, and this is going to be 0, and this is going to be minus 4 again, and that's how they got minus 4 right here again. Now let's code it. All right, so what's the first step in coding? We know we're going to start with org 100. Looking at the Python code, we know we have 3 loops. We have the inner loop and the outer loop, and for us to perform multiplications, we're going to need another loop. We're going to name our loop loopy, and we are going to load x, and we're going to declare x. X is going to be 9, and the reason why x is 9 in this loop, x is going to start at 9, and we are going to substitute we're going to substitute 8 from it, and we have to assign 8 decimal is going to be 8. Now for those of you who haven't who is this your first time learning loop, I have a video teaching you about loops from basics of loops, and if this is your first time doing Mari, I also have a video teaching you that. But for those of you who have been following me, let's continue. So why did I do this? I loaded x and I substituted 8 from it, and I'm going to store it in first val, and we have to assign first val. We're going to say first val is going to be equals to 0. Now, why do I say first val is equals to 0? Because what we want to do is we want to load x, which is 9, and we want to substitute 8 from it and store it in first val. So first val holds whatever this operation does. So 10 minus 8 is 2. 2 is going to be stored in first val. Y, we're going to load y, and we're going to store it in second val, and we have to assign second val. Second val is equals to 0. Now we need a counter. We're going to call the counter z. So we're going to load z, right? And what do we want to do with z? We want to substitute 1 from z and want to store z. Now z is the counter for the inner loop. You guys should guess what z is going to be in the comment section. Type in your answer, and if you get it, comment that you got it. Now z is going to be in the inner loop. Z is only going to run 4 times, because this loop is going to run 4 times before coming to this loop. So z is going to be equals to 4. We also have to declare a variable called 1. Z is equals to 0, and if z is not equals to 0, we would like to jump to the multiplication loop, and we'll call the multiplication loop mult. We would like to load x, which is, for instance, 10, substitute 8 from it, so that is 10 minus 8 will be equals to 2, and we'll store 2 inside first val. Now we want to load y, 0, store it in second val, then load z, that's the counter, substitute 1 from it, and check if it's 0, and if it's not 0, you should jump into mult. And if it is 0, what do we want to do? We want to load y and substitute 4 and store y. So now we need to make a variable called 4. So in the case of the inner loop is done, we would like y to be 0 once again, and we would like the counter for y to be 4. Y is 0, and after the loop runs, y is going to be 4, and once we are going out of that loop, we would want y to be reset back to 0. Let me explain it again. If we load x, let's say x is 9, we substitute 8 from it. Now that is 1, and we store it in first val. So first val is 1. Then we're going to load y and store it in second val. That is y is 0 initially. Now second val is 0 and first val is 1. Then if every time we do this, we want to load z, substitute 1 and store it in z, and we want to check if z is equals to 0, because if z is equals to 0, we want to load y, substitute 4 and store y. We want to also reset z as load and add 5. Oh no, we add 4. The z is meant to be 5, not 4. Let's check it out. Z is meant to be 5. because it's 5, we have to create its own variable for it. Then we store it in to jump to loop. Loop is this is for x in range 9 to 18. That's the outer loop. But before we do that, let's define the multiplication loop. So that's mult. What do we want to be done in the multiplication loop? We want to load second val, to store it in a variable. We'll call the variable multi, and we would assign multi to be 0. And what do we want to do? We want to load first val, and we want to substitute 1 in first val. So in this case, first val is going to be the counter for the multiplication table. Now I want to load second val, and we want to add y to it and store in second val. Load first val, and we want to check if first val is equals to 0, right? Because it's the counter for the multi loop. And if it's not equals to 0, we want to jump back into multi. And if it's equals to 0, we want to load multi. So we want to jump back into mult, and if it's 0, we want to load multi. We want to load multi and substitute it by 4, which is this one right here. Substitute it by 4. There's a variable called 4, so that's good. And we want to output the result. Yes, that's what we want to do. We want to output the result, and we want to load y, add 1 to it, and store it in y. We want to jump back to loopy. This is the multiplication loop. So if you look at this one right here, we need first val and we need second val. We need to know what first val is, and we need to know what second val is. Now, usually, first val in this case is x, which is 9. 9 minus 8 will be equals to 1. Let me say 9 minus 8 right here. 9 minus 8 will be equals to 1. And second val is going to be 0. And whatever you get from this, we'll minus it from 4 and get minus 4. So x is equals to 9. But what we want to do in this case is, instead of making first val x, we want to minus x with 8 and store the value in first val. And whatever y is, we want to assign it to second val. And we want to go into this mult loop and load second val, in this case 0, and store it in multi. Multi is going to be your final answer, or multi is going to be the not the final answer, but a variable where we're going to store it in. We want to load first val, which is in this case 1, and we want to substitute 1 from it and store it in first val. And then we want to load y, which is 0, and store second val. So this loop is very interesting because from this place to this place, so for every time we add y to second val, we are going to be minusing 1 from first val. That's the trick to it, right? So what this loop says is load first val, substitute 1 and store it in first val. So first val is equals to 0, right? And this is now the main one. It says load second val. Remember, first year second val was 0 and multi is 0. That's your final answer, is 0. Okay, so it says load second val, add 0 to it, and store second val. So second val is equals to 0 again. Then it says load first val and check if first val is equals to 0, and if first val is equals to 0, it should load multi and substitute 4 from it, and this will be your final answer, and output it. Then load y, add 1, store y, and jump to loopy, which is back into this loop. Whereas this loop says load x is still going to be 9, so the first val is still going to be 1. Load y now is going to be 1 because we added 1 to y here, and store it to second val. So second val is 1. We're going to load z, substitute 1, store z, that's the counter. Then we're going to check if z is equals to 0, and because it's not equals to 0, we're going to jump back into mult and do this whole loop again. But in the case where x is equals to 0, we're going to load y and substitute 4 from it and store it in y. And the reason why we do this is because by the end of the whole loop, once z is 0, y would be 4 because we kept on adding 1 to y every time you went to this place, and we kept on minusing z by 1, which is the outer loop. And what we want to do in loop is we want to load x. Loop is very easy, actually. Loop is the easiest one. We want to add 1 to it, because if you look at it, it's incrementing or decreasing. So we want to add 1 to it, and we want to store enter. So we want to load this counter. We could call the counter p, and as usual, we want to substitute 1 from it, and we want to store p. So what is p? In this case, p is going to be how many times the outer loop is going to be run, which is 10, 11, 12, 13, 14, 15, 16, 17, 18, which is 9 times. So p is going to be 9. And we want to store p, and we want to check if p is 0, and if it is 0, we want, and if it's not 0, we want to jump back into the inner loop and do the whole process again. Or if it is 0, we want to halt, and that is all. So let's save it. Yeah, let's save it, and let's assemble it. Oh, there's an error. Let's check the error out. It says jump this, so we just have to change this and put it in small letter L. That was the mistake. And if we assemble it, that is all. And file, I'm going to load, I'm going to go to downloads, I'm going to go to and we are going to run it and see what happens. Oh, so make sure you make this decimal unless it's going to have some problems. So let's reload it again and let's run the code. In this I'm going to compare with this and minimize this. This is where it is. 12, 20 minus 4, 5, 14, 23, and that is all. And we have successfully done the whole code. We have done the whole code. So make sure if you found this useful, make sure you like, comment what you learned, and subscribe for more videos like this. I'm going to be uploading more videos like this. And if you guys have any video in mind or any topic in mind, kindly let me know, and I'll always be checking the comment section. I'll be replying with you guys. And that is all. Thank you all.